Hello guys, welcome to another video of Kubernetes. In this video, we are going to discuss about replica sets and replication controllers. How we can create them using Kubernetes manifest file with YAML. Okay, so let's begin the video. We'll be covering below topics, all these topics in this video. First, what is replication controller and replica set? We'll be covering the differences as well. What is a small or minor difference between these two? We will be seeing a YAML manifest structure for creating replication controller and replica sets, and we'll also see how we can deploy them, how we can create the Kubernetes manifest for them, and how we can deploy them step by step with examples. Okay, let's go ahead. Let me start by just giving you brief introduction about replication controller. So if you are creating the replication controller, this ensures that a specified number of pods are running at all the times. So suppose if you have created a replication controller and you have one pod, and if something goes down in your pod or something happens, some networking issue or some any patching issues, then your pod will go down. In that case, your application will also go down. But if you are creating replication controller will make sure that if one pod is down, another pod will always be up and your application will be working. So suppose you have given a replication controller as 5. You are creating 5 pods in the replication controller. Even if one pod is down, 4 pods will be running and another fifth pod will be automatically created by replication controller. Okay, so your application will be running at all times. Okay, this monitors and replaces pods if they fail, which we already discussed. What is replica set? This is, you can say, the advanced version of replication controller. Okay, this also ensures a specified number of pod replicas are running at any given time. Even in replica set, if some pods are failed or some are corrupted, then it will make sure that the replica set, the number of pods which you have specified while creating the replica set are always running. So suppose you have created replica set of 5 pods, and due to some reason or something 2 pods are down, then immediately replica set will go ahead and spin up 2 pods. Okay, so it will make sure 5 pods are always running and your application is never down. This supports set-based label selectors and rolling updates. Okay, so there is a feature, you can say, in replica set of set-based label selectors which a replication controller doesn't support. Okay, so this is the difference between replica set and replication controller. Replica set just supports set-based label selectors and rolling updates, but in case of replication controller, that doesn't support it. Okay, we'll discuss what is set based label selectors and rolling updates later in the video. What is the difference between replication control and replica set? We already discussed this. Replication controller supports only equality based selectors, and replica set supports set based selector and rolling updates. Okay, if you are creating replication control, you have, if you have a specified 5 replicas of pod, 5 pods will always be running. Okay, and you won't have to select any pods if they are already created or something like that. But in case of replica set, you can specify selectors and match label which will match with the metadata of pods. If any pods are there with that metadata name, then it will that pod will be part of this replica set. This replica set will automatically acquire basically that pod, and anything happens with that pod will be managed by this replica set. This also supports rolling updates when we create replica sets in the deployment. But in case of replication controller, generally this doesn't support the rolling updates. Most of the people now use replica sets because replication controller is old and replica set 1 is the new, and it supports set based selector, which is very good for creating the pods and managing the deployments. Let's now see the YAML structure for application controller. There is a minor difference. You can see the API version is v1 for application controller and kind is replication controller. You can specify the metadata name, that is name my replication controller. You can specify anything you want, and in spec, in my previous video we already had discussed the component of YAML: API version, kind, metadata, and spec. These are the only four important components of the Kubernetes manifest file. The API version is v1 for replication controller, kind is replication controller because we are creating the replication controller. Metadata, we have added the name. In the spec, we have given three replicas. So at all the time, three replicas will be running of this pod which we are creating. Selector we have given as app, my app, and in template you can see we have given this template of pod. Okay, in spec you can import multiple templates, or you can add multiple templates as well for pods or service or whatever you want. Okay, so if you notice carefully, replica is equal to 3 and selector, and rest everything is template, metadata, labels, app, my app, and spec, containers, name, and image. So this all from template to here in the containers image. This is nothing but Kubernetes manifest YAML of a pod. Okay, so to create the replication controller or replica set, generally we provide the replicas selector, and inside the template we just provide the template of the pod, that is YAML template of creating the pod. Okay, so this will create the replication controller. If you notice it here in the selectors, we just have given the app and my app. We have not given the match labels, so it will not be able to match that, and it will not this replication controller will not acquire those pods. Okay, now let me, if I explain this in different way, like if you are creating 5 replicas of pod, then all the pods will be running inside this replication controller. You cannot add the labels and match labels, and you cannot add the pods which are having same match label in replication controller, but in replica set you can do that. So this is just one difference between these two. Now let me go ahead and check the YAML structure for replica set. If you notice carefully, everything is almost same. The API version is different, that is apps/v1. You can get the API version from Kubernetes official documentation. Here in kind we have given the replica set because we are creating the replica set. Metadata, we have provided the name my replica set. In spec, like how we have done in replication controller, we have provided the replicas, that is 3, so that 3 pods will be created at every time. And in selector, here we have given the match labels, and here we have given the app colon my app. And if you see here in this template, pod template, we have given metadata, labels, and app and my app. So this match label will match the metadata of this pod, and this pod will be automatically part of this replica set. Okay, this pod which is being created with this container, my container nginx 1.14.2 version, and this pod will be part of this replica set. So whenever any pod between these two goes down, another third pod will be automatically created by the replica set. So this is the advantage of replica set, which you can use to get the high availability of your applications. If you host your application in single pod, if that pod goes down, then your application will also go down. But if you are creating the replica set, suppose three instances of your application is running, even if one instance goes down, two are already there, right? And generally replica set takes just a second or even less than that to create another replica of your pod. Okay, so that it will make sure that your application is never down. And if you notice, there is just the minor difference between replication controller and replica set. Here in the selector we have provided match labels here to match the labels which we have given in the pods, so that all these pods which we are creating will be part of this replica. Even if some pods or something or some, you can say, pod are created from different deployment, and if they are having same labels as my app, those pods will be part of this replica. Okay, so this is how replica set works, but you cannot achieve this in replication controller. How you can create the replication controller? First we have to create the YAML file, which we already have seen how we have to create the YAML file for replication controller. Then you can again apply this command kubectl apply -f, and you will have to give the file name. So this will create the replication control in your Kubernetes environment. Once that is done, you can check the status by running this command kubectl get replication controllers. So this will get you details of all the replication controllers. Now once everything is done, you can verify by kubectl get pods. So you'll be getting all the three pods which you might have created using the previous replication controller.yaml manifest file. Okay, same is the case with replica set as well. First we create the YAML file. After that we apply that YAML file so that replica set will be created. If you just type this command kubectl get replica set, you will be getting all the information about your replica set which is just created. And if you type kubectl get pods, you will be getting all the pods inside the replica set using this command, and you will be getting the name of replica as well, for which or these pods are part of. Now let's discuss what are the best practices when we use replica set and replication controller. So it is always recommended to use replica sets for NIP deployments because you can scale this efficiently, you can use match labels, and even you can perform rolling update or rollback whenever something goes down using the deployments. So it is best to use replica set for any of the deployment in Kubernetes. We need to define clear label selector for proper pod management. We just have seen we'll have to specify the selectors and match labels in replica set and replication controller so that all the pods will be part of that replica set. So we'll have to make sure that we are specifying clear labels and selectors. and we can version control our YAML files so that we can deploy that with our CI/CD pipelines or local computer. Okay, so always make sure you are just adding your YAML files or creating your YAML files in the version control. You can use namespaces as well to isolate environments, which we have already discussed in my previous video. Okay, so let's now recap this. Replication controllers and replica sets ensure pod availability. If you are hosting your application in single pod, then your application may go down if pod is down. Then if you are hosting your application using the replication controller or replica set, this will make sure that your application is always up by making sure that all the pods inside that replica sets are always running. Okay. YAML, you can define configuration file, Kubernetes manifest file using YAML for both to create replication controller and replica sets. You can use replica sets for modern Kubernetes deployment. You cannot use replication controller as part of deployments in Kubernetes. Use replica sets for Kubernetes deployment so that you can match labels with pod and will all the pods with that label will be added to this replica set. Okay, and if you have created the replica set in the deployments, will be able to perform the rollback. If you something goes down or if your new upgrade is not running, you can always go ahead and roll back your changes using the deployments and replica set easily and efficiently without affecting your application. Your application will always be up if you are using replica set and Kubernetes deployment. Okay, that's it from this video. If you liked it, please like and subscribe my channel. If you have any questions, please let me know in the comments. Thanks for watching.